Now you want to know whether a given function is odd, even, or neither. So first of all, I'm going to write down what each of these terms mean. So we say that a function is even if f of x is equal to f of negative x. So basically, if you replace x with negative x, the function remains exactly the same. And you say that the function is odd if what happens is f of negative x becomes negative of f of x. So if you switch the x to negative x, the entire function gets a negative sign. And if neither of the above happen, well, then it's neither. Okay, so let's see which of these cases we have here. So we have f of x equals negative 3x to the fifth plus 14. In order to discern whether this is odd or even, we're going to need to find out what f of negative x is. So that's negative 3 times negative x to the fifth plus 14, which is, well, negative 3, and negative x to the fifth is negative x to the fifth, because 5 is an odd power, so the negative sign is retained, plus 14. And negative 3 times negative x to the fifth is positive 3x to the fifth plus 14. You will see that the function has not remained the same. F of x that you had is negative 3x to the fifth plus 14, and what you have now is 3x to the fifth plus 14. Nor is it true that this is not equal to the negative of f of x either, because in that case both the signs should have switched. So in this case we would like to say that the answer is actually that it's neither. Okay, what about, we need to evaluate the function at the given values of the independent variables and simplify. So we've already worked out this part, f of negative x, so I'm just going to write that down here, 3x to the fifth plus 14. And for f of 3, well, you're going to have to take the original function and work this out. So f of 3 is negative 3 times 3 to the fifth plus 14. That's negative 3 times 243 plus 14. That's equal to negative 729 plus 14, which is equal to negative 715. And that's the answer. So f of 3 is negative 715.